Anyways, let's take a look at this question. Okay, let X be the number of microchip and Y be the number of resistors selected. There are 4 microchips, 2 resistor and 1 capacitor, and 3 components are selected without replacement. For joint probability distribution, I use combination to find each joint probability. This is all the joint probability that I can find. Okay, this value forms the joint distribution table. For marginal distribution, I sum the rows and I will get Gx. G0 is equal to 1 over 35, G1 is equal to 12 over 35, G2 is equal to 18 over 35, and G3 is equal to 4 over 35. For Hy, I sum the columns and I will get 2 over 7 for H0, H1 is equal to 4 over 7, H2 is equal to 1 over 7. To test independence, I check whether Fx0, Fx3 and Y0 is equal to 4 over 35. But G3 times H0 is equal to 8 over 245. Since they are not equal, X and Y are dependent. For expected value, the formula is X, the sum of X times Gx. So as you can see, the answer is 12 over 7. For Ey, it is the same, it's sum of Y times Hy. And the answer will be 6 over 7. Okay, for question 1b, from the given table, I can find the marginal distribution of Y equal to 1, Y equal to 2, and Y equal to 3. And next is for X equal to 1 and X equal to 2. For the conditional probability, X is greater and equal than 2 and Y is equal to 1. I use P X equal to 2 and Y equal to 2 over H2. So 0.22 over 0.35, I will get the answer 22 over 35. Next, covariance. First, I find EX it is equal to 1.57, EY it is equal to 1.87, and EXY equal to 2.88. For covariance XY is equal to EXY minus EX times EY, and the answer will be 0.0559.
Okay, now let's take a look at question number 2. So it wants to find the marginal density of X and Y. So first of all, we gotta make it as dx, and we take the constant out first, and then we integrate it and we plug the value in, and we should be getting our answer. Alright, now for Y, we gotta make it as Hy, and same as before, we take the constant out and integrate it and plug the value in, and this is our final answer. So next, for the second question, it wants the probability of X plus Y less than equal to 2. So this is our sketch graph, and by the equation we can simplify it into Y less than equal to 2 minus X. Okay, now to find the probability, we gotta double integrate it, and first of all we should integrate it respective to Y, and then we plug in the value of Y, and then we integrate it respective to S and plug in the value of X in it, and then finally we should be getting our answer, that is 1 over 15. Okay, for question B, this is our given equation, and to find expected x, we gotta integrate our equation, but the equation is multiplied by x. Okay, so first of all, we should integrate our equation respective to respective to x, and we plug in the value of s, and we integrate y, and we put the value of y in it, and when we relate it, we should be getting 4/5. So for EY, same as before, but this time we multiply our equation with y. So we integrate respective to x first, and we plug in the value of x, and then we integrate respective to y and put the value in, and then we should be getting our answer. And for xy, we will multiply our equation by xy, and then we do it same as before, integrate, plug in the answer, the value, and calculate it. We will getting 4/9. But for covariant, this is our formula to get it. We put in the calculated answer, and then we will get 4/225. And since it's not equal to 0, x and y are dependent. Okay, that's all from me.